Hello students, welcome to another session of this integral calculus. In this session, we will be discussing methods of integration. So basically there are three methods that we are going to study in this chapter. First one is integration by substitution. Next, we'll be studying integration using partial fraction method and integration by parts. So first we will be dealing with integration by substitution. Now see here, when this method is applicable, so while evaluating integrals, it is depends on by which method you are going to apply. So you have to identify by which method it has to be evaluated. Unless you identify the method, it is it's going to be very tough. Okay, so the substitution method is used. See here, this method is used when the derivative of one function in the integrand is within the integrand. Means one function the derivative ಅಲ್ಲೇ ಒಳಗೆ ಇರುತ್ತೆ ಇಂಟಿಗ್ರಲ್ ಒಳಗಡೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನೋಡಿ, ಯಾವ್ಯಾವ ಸಂದರ್ಭದಲ್ಲಿ ಇದನ್ನ ಬಳಸ್ತಾರೆ, ಈ ಟೈಪ್ ಇದ್ರೆ, ಸೊ ದಿಸ್ ಕ್ಯಾನ್ ಬಿ ಯೂಸ್ಡ್, ದಿಸ್ ಮೆಥಡ್ ಕ್ಯಾನ್ ಬಿ ಯೂಸ್ಡ್, this method can be used in the following cases. ನಾನು ಕೆಲವು ಮಾತ್ರ ಬರಿತಾ ಇದ್ದೀನಿ. ಹೇಗಿರುತ್ತೆ ಅಂತಂದ್ರೆ, ಅಂಡರ್ ದ ಇಂಟಿಗ್ರಲ್ ಸೈನ್ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಒಂದು ಫಂಕ್ಷನ್ ಇರುತ್ತೆ, ಅದರ ಡೆರಿವೇಟಿವ್ ಇಲ್ಲೇ ಇರುತ್ತೆ. ಇದು ಎಫ್ ಎಕ್ಸ್ ಇರ್ಬೋದು ಅಥವಾ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಪವರ್ ಎನ್ನು ಇರ್ಬೋದು, ನೋ ಇಶ್ಯೂ. ಸೊ ಇದರ ಡೆರಿವೇಟಿವ್ ಇಲ್ಲೇ ಇರುತ್ತೆ. ಅಥವಾ ಹೀಗಿರ್ಬೋದು, ಇ ಪವರ್ ಎಫ್ ಆಫ್ ಎಕ್ಸ್, ಆಮೇಲೆ ಅದರ ಡೆರಿವೇಟಿವ್ ಇಲ್ಲೇ ಇರುತ್ತೆ, ಇದರ ಡೆರಿವೇಟಿವ್ ಇಲ್ಲೇ ಇರುತ್ತೆ. ಆರ್ ಯು ಮೇ ಹ್ಯಾವ್ f dash in the numerator and f of x in the denominator. ಇದರ ಡೆರಿವೇಟಿವ್ ಇಲ್ಲೇ ಇರುತ್ತೆ. ಅದೇ ಥರ ಯು ಮೇ ಹ್ಯಾವ್ ಅಂಡರ್ ರೂಟ್ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ and its derivative somewhere here. Or you can have integration of f of x power n into derivative of fx, f dash x. Okay, so in such case we use the method of substitution. ಅಂತಂದ್ರೆ you have to check ಫಂಕ್ಷನ್ಸ್ ಅಲ್ಲೇ ಇರ್ತವೆ, ಒಂದರ ಡೆರಿವೇಟಿವ್ ಅಲ್ಲೇ ಎಲ್ಲೋ ಕಾಣ್ತಾ ಇರುತ್ತೆ. ಸೊ ಇನ್ ದ್ಯಾಟ್ ಕೇಸ್ ವಿ ಯೂಸ್ ದ ಮೆಥಡ್ ಆಫ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್. ಸೊ ವಿ ವಿಲ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ವಿತ್ ದ ಹೆಲ್ಪ್ ಆಫ್ ಎಕ್ಸಾಂಪಲ್. ಓಕೆ, ಸೊ ಇಂಥ ಸಂದರ್ಭದಲ್ಲಿ ಏನು ಮಾಡಬೇಕಂತಂದರೆ, ಒಂದರದ್ದು ಡೆರಿವೇಟಿವ್ ಅಲ್ಲೇ ಇದ್ದರೆ ಯು ಹ್ಯಾವ್ ಟು ರೀಪ್ಲೇಸ್ ದಿಸ್ ಫಂಕ್ಷನ್ ಬೈ ಟಿ. ದಟ್ ಈಸ್ ದ ಬೇಸಿಕ್ ಥಿಂಗ್. ಓಕೆ, ಸೊ ಇನ್ ಆಲ್ ದ ಕೇಸಸ್ ಯು ಹ್ಯಾವ್ ಟು ಪುಟ್, ಇನ್ ಆಲ್ ದೀಸ್ ಕೇಸಸ್ the working procedure is, in all these cases we substitute, we put f of x is equals to t and we obtain f dash from this. You have to differentiate. This is the working procedure. Differentiate with respect to x. So you will get f dash x is equals to dt by dx and you may write f dash x dx is equals to dt. ನೋಡಿ, ಈ ಟರ್ಮ್ ಅಲ್ಲಿ ಇದ್ದೇ ಇರುತ್ತೆ. On substitution, this term used to be within the integrand. Okay, so that is the reason why you have to put f of x is equals to t and f dash x dx as dt. So we will understand with the help of an example in a better way. Okay, so here is the example. Suppose this is the question, evaluate integration. I will be taking simple example, sine inverse x by under root 1 minus x square dx. Okay, now see here, you might have seen this 1 by under root 1 minus some x square somewhere else. You under root 1 by under root 1 minus x square ಅಂದ್ರೆ ಅದು ಡೆರಿವೇಟಿವ್ ಆಫ್ ಸೈನ್ ಇನ್ವರ್ಸ್ ಎಕ್ಸ್. ಅದಕ್ಕೆ ಹೇಳ್ತಾ ಇರೋದು ಡೆರಿವೇಟಿವ್ ಫಾರ್ಮುಲಾಸ್ ಪಕ್ಕಾ ಬೇಕು. ಸೊ ಅದು ಗೊತ್ತಿಲ್ಲ ಅಂದರೆ ಇಲ್ಲ. ಓಕೆ, ಸೊ ಹಿಯರ್ ಐ ಕ್ಯಾನ್ ರೈಟ್ ಇಟ್ ಆಸ್, ನೋಡಿದ ತಕ್ಷಣ ಗೊತ್ತಾಗುತ್ತೆ ಬೈ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಅಂತ, ಯಾಕಂದರೆ ಸೈನ್ ಇನ್ವರ್ಸ್ ಎಕ್ಸ್ ಡೆರಿವೇಟಿವ್ ಇಲ್ಲೇ ಇದೆ. ಸೊ ಯು ಹ್ಯಾವ್ ಟು ರೈಟ್ ಇಟ್ ಆಸ್ sin inverse x into sin inverse x the derivative is to 1 by under root 1 minus x square ಬರುತ್ತೆ. So for your understanding I can write this, ಈ 1 by under root 1 minus x square I am writing it. Okay, this is written in this form. ಯಾಕೆ ಅಂತಂದರೆ ಇದ್ರ ಡೆರಿವೇಟಿವ್ ಇಲ್ಲಿ ಕಾಣಲಿ ಅಂತ. ಸೊ ಈಗ ಗೊತ್ತಾಯ್ತು ನಿಮಗೆ, ಇದ್ರ ಡೆರಿವೇಟಿವ್ ಇಲ್ಲೇ ಇದೆ, ಕೊಟ್ಟಿದ್ದಾರೆ ಅವರೇ. ಓಕೆ, ಸೊ ಯು ಆರ್ ಗಿವನ್ ಡೆರಿವೇಟಿವ್ ಆಫ್ ದಿಸ್ ಇಸ್ ಹಿಯರ್. ಸೊ ಯು ಕ್ಲೀನ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್. ಸೊ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ or put sin inverse x is equals to t. You can take any another variable, so I have taken t. From this you obtain the value of dx or sin inverse x dx. So differentiate with respect to x. So derivative of sin inverse is 1 by under root 1 minus x square. Derivative of t with respect to x is dt by dx. Okay, now cross multiply. So what we will get, bring this dx this side, it's a 1 by under root 1 minus x square into dx equals to dt. Okay, so this is what you got, this term as dt and this is your t. Now you got the very simple function. Therefore your I becomes integration of, look at this, what we had, sine inverse. Sine inverse means t. It is t into this. This means your dt. Okay, so this is your dt. Now what is the integration of t with respect to t? Okay, like a integration of x. Integration of x with respect to x is x square by 2. So similarly integration of t with respect to t is t square by 2 plus constant c. Okay, remember this, integration of x with respect to x is x square by 2. In the same way integration of t with respect to t is t square by 2. And finally you have to replace whatever your t ಅಂದರೆ ಏನು ತಗೊಂಡಿದ್ದೀರಾ, t ಅಂದರೆ sin inverse x ಇದೆ. So sin inverse x whole square by 2 plus c, because your t is sin inverse x. So this is how you can use the method of substitution. Let's have another example. Suppose you are asked to find the integral of suppose the question is integrate tan inverse of 1 by 1 plus x square with respect to x. Okay, so let I is equal to, you have to take integration tan inverse x by 1 plus x square dx. Now look, immediately derivative of tan inverse is 1 by 1 plus x square. So this is here. So for your understanding, I can write it as a product of two terms, tan inverse x, and its derivative is here. So I can write it as, okay, so its derivative is here. This is your fx, this is your f dash. So substitute. I can call it as number 1. Put tan inverse x is equals to t. Differentiate with respect to x. So the derivative of tan inverse is 1 by 1 plus x square equals to dt by dx. Bring this dx this side. So 1 by 1 plus x square into dx equals to dt. So make the substitution here. This is t and this is your dt. So this implies your I becomes t into dt. Okay. So integration of t is t square by 2 plus c. So it is t is your tan inverse x whole square by 2 plus c. This is your value of integral. Okay. Now one thing to be noted, better you make note of this. It may help somewhere else in solving differential equations or in case of CT. So integration of f of x into f dash x dx is always equals to f of x whole square by 2 plus c. Okay, in here in both the cases, previous cases, what we had, this is your f, this is your f dash, its derivatives here. So what was the final answer? Tan inverse x whole square by 2. Similarly, we had sin inverse x by root 1 minus x square. Okay, so directly in case of CT, suppose if you get, you can write directly integration of sin x into cos x dx. One can write directly what is the derivative of sine. Derivative of sine is cos x here, so its integration you can write immediately. It is sine square x by 2 plus c. Let me write integration of log x into 1 by x dx. Indirectly it is log x by x. Okay, so derivative of log x is 1 by x is here, so you can write immediately log of x whole square by 2 plus c. Likewise, integration of, suppose you have tan x into sec square x dx. Directly derivative of tan is sec square here, so you can write it as tan square x by 2 plus c. Okay, so we will be having more situations of this kind, so better you remember this one, right? So I will be doing some examples. So directly I move on to exercise and then remaining examples I'll solve. So we will be discussing exercise 7.2 in detail. So here is the first example. You are asked integrate the functions. Integrate 2x by 1 plus x square with respect to x. Okay. So you have to call I is equal to integrate with respect to x means you have to put this sign 2x by 1 plus x square with respect to x means you have to take dx here. This is the way of writing this given question. Now look, what is the derivative of this? Derivative of 1 plus x square. Derivative of 1 is 0, derivative of x square is 2x. Ille ide adu. Okay, so derivative of this is present here. So I can write it as, or substitute, put 1 plus x square is equal to t because its derivative is 2x. That is the reason. So differentiate with respect to x. What you will get? X square derivative is 2x. One derivative is 0. So you should not write. Derivative of t with respect to x is dt by dx. So we have 2x dx here. So that is why I am making this arrangement. 2x dx is dt. Therefore I becomes, carefully see here, 2x into dx. 2x into dx is, this 2x into dx is dt. So I can write dt in the numerator. Divided by 1 plus x square you have taken as t. So this is your t. 1 plus x square. Okay. Now very easily integration of 1 by t is log t plus constant c. So log of t have taken 1 plus x square. So very important property is that you better note down this. Note this. This will help you a lot while solving differential equations. Means if numerator is the derivative of denominator. Okay. If numerator is the derivative of denominator, its integration will be always log of denominator. Its integration will be always log of denominator. That we got here. Illi nodi illi éniде, idar derivative illi ide, derivative of 1 plus x square is 2x. So final answer is log of this. Okay, so this is true for all integrals. So better remember this property. In many situations it comes. So whenever the situation arises, you have to use this. I'll be giving some sample examples. Suppose if you have secant square x by tan x dx. Look at this. Derivative of tan is secant square. So if it is for 1 mark or in any situations it arises, so immediately can keep it as log of denominator. Okay, in case of differential equations we use this. Suppose if you have integration of, say, x, say 3x square by 1 plus x cube dx. Now see here, what is the derivative of this? Derivative of this is 3x square. It is out here. So one can write directly it is log of 1 plus x cube plus c. Integration of, say, cosec square x by cot x dx. Okay, so what is the derivative of cot? It is minus cosec square. So minus cosec square means you can multiply and divide by minus. So I can write minus minus here. So you will get final result minus of log of cot x plus c. Further, integration of, suppose if you have a situation like this, x by 1 plus x square dx. So its derivative is 2x. So here 2 is not there, means multiply and divide by 2. So just make arrangement. It's 2x by 1 plus x square dx. Now look, derivative of 1 plus x square is 2x here. So you can write directly it as log of 1 plus x square plus c. Okay, in case of differential equations you use this property, because every time solving by substitution in case of differential equation is quite lengthy, so you can make use of this result directly. Okay, so let's have another example from exercise 7.2. So this is 2. You're asked integrate log of x whole square power x with respect to x. Okay, so let us call I is equal to it is log of x whole square by 1 by x, that is by x, and dx. This is a way of writing integration of this with respect to x. Okay, this is equals to, I can write derivative of log x is 1 by x, so I can write it in better way so as to understand. Derivative of log x is 1 by x, so it is out here. Okay, so this by x is written as 1 by x dx. Now clearly see that derivative of log x is 1 by x. Forget about square. Okay, so now put log of x is equals to t. So you have to put log of x is equals to t. Differentiate with respect to x. Okay, so derivative of log x is 1 by x equals to dt by dx. Otherwise one can write directly 1 by x dx is equal to dt. This is 1 by x into dx is equal to dt. Okay, now see here, we have this 1 by x dx, you have to replace it as dt and log x as t. So whatever I becomes, so your I becomes, this is your 1, I can call it as 1. Therefore 1 becomes I is equal to integration of log x whole square is there, log x means taken t, so this is t square, and 1 by x dx is dt. Look at this, this is your t and this is your dt. Okay, now integration of t square is t cube by 3, that we all know. Integration of x square is x cube by 3. In the same fashion, it is t cube by 3. Now you have to replace integration of t cube. T means you have taken it as log x. So it is log x whole cube by 3 plus c. Okay. So again, one property you need to think. From this, note down integration of, if you find something like this, f of x power n, and if its derivative is somewhere here, you can write it as f of x power n plus 1 by n plus 1 plus c. So same thing happened here. ನಮ್ಮಲ್ಲಿ ಏನಿತ್ತು ಅಲ್ಲೇನಿತ್ತು ನೋಡಿ ಇಲ್ಲಿ log x whole square into ಇದು log x derivative ಇಲ್ಲೇ ಇತ್ತು. ಅದಕ್ಕೆ ಫೈನಲ್ ರಿಸಲ್ಟ್ ಈಸ್ ಇದಕ್ಕೆ ಕ್ಯೂಬ್ ಬೈ 3 ಬಂತು. ಓಕೆ, ಸೊ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನೋಡಿ, ಇನ್ ಕೇಸ್ ಆಫ್ ಸಿ ಇ ಟಿ ಇಟ್ ಹೆಲ್ಪ್ಸ್ ಅ ಲಾಟ್. ಸಪೋಸ್ ಈ ಥರ ಇದ್ರೆ ನಿಮಗೆ sin power 4x into cos x dx ಅಂತ ಬಂದರೆ ನೇರವಾಗಿ ಇಡ್ಬೋದು. ದಿಸ್ ಇಸ್ ಯುವರ್ ಎಫ್ ಎಕ್ಸ್, sin x ಅಂದರೆ ಎಫ್ ಎಕ್ಸ್, ಅದರ ಡೆರಿವೇಟಿವ್ ಇಲ್ಲೇ ಇದೆ. ಸೊ ಯು ಕ್ಯಾನ್ ಕೀಪ್ ಇಟ್ ಆಸ್ sin ಪವರ್ 5x by 5 ಪ್ಲಸ್ ಡೈರೆಕ್ಟ್ ಆಗಿ. ಓಕೆ, ಇಫ್ ಇಟ್ ಇಸ್ ಫಾರ್ 1 ಮಾರ್ಕ್ ಯು ಮೇ ಕೀಪ್. ಅದೇ ಥರ ಸಪೋಸ್ if you are having tan inverse of x square by 1 plus x square. Okay, so derivative of tan inverse x is 1 by 1 plus x square. So you can write it as directly tan inverse x whole cube by 3 if situation arises. Otherwise you can do it by substitution. Put tan inverse x is equal to t and do it as usual. So but whenever the situation demands for quick result, you can make use of this. Let's have another example. Question number 3. You are asked to integrate this function. You are asked to integrate 1 by x plus x log x. You are asked to find the integral of this. Okay. Now you make one change here. Take x common. 1 plus log x dx. So I can write this 1 by x as 1 by x whole divided by 1 plus log x. Now see here, what is the derivative of 1 plus log x? Derivative of 1 is 0. Derivative of log x is 1 by x. So ille ide. This is of the form f dash by f. So either substitute or directly you can write it as this is log of 1 plus log x plus c, because better you mention the property integration of f dash by fx is it's log of f of x. Okay, if its derivative is here, you can keep direct result. Yes. Next, example number 4. You were asked to find the integral of sin x into sine of cos x. Okay, you are asked to integrate this with respect to x, means you have to write like this. So what about this? Got any idea? Now see here, derivative of cos x, we know it is minus sin x, so sin x is out here. Okay, so I can write like this. I'll make some rearrangement. Sine of cos x, sine is a function of cos x, into, I can write this as sin x into dx. Okay, the reason is to make visibility of derivative of cos is sin x. Okay, so now you got derivative of this is somewhere here, so put cos x is equal to 2. ಇದರ ಡೆರಿವೇಟಿವ್ ಇಲ್ಲೇ ಇರೋದ್ರಿಂದ ಈ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡ್ತಾ ಇರೋದು. ಇದನ್ನ ಡಿಫರೆನ್ಷಿಯೇಟ್ ಮಾಡಿ cos ದ ಡೆರಿವೇಟಿವ್ ಮೈನಸ್ sin x ಬರುತ್ತೆ, ಈಕ್ವಲ್ ಟು dt by dx. ನಮಗೆ ಇಲ್ಲಿರೋದು ನೋಡಿ, ಇಲ್ಲಿ ಏನಿದೆ sin x dx ಇರೋದ್ರಿಂದ ನಾನು sin x dx ಅಂತ ಬರ್ಕೊಳ್ತೀನಿ. ಈ dx ಈ ಕಡೆ ಬಂತು, ಮೈನಸ್ ಈ ಕಡೆ ತಗೊಳ್ತೀನಿ, minus dt. Okay, now make the substitution in this. This is your 1. Okay, so therefore 1 becomes I equals to integration of this sign as it is and cos x is t, so it becomes sin t. Remember this cos x means t, into this sin x dx. This sin x dx is minus dt, and you have to write it in bracket. Okay, so minus outside, integration of sin t. So integration of sin is minus cos t plus constant c. So this is cos, minus into minus plus, cos t. T is what? T is again, you have taken t, you have taken as cos x. So t is your cos x, so I can write it as cos of cos x plus c. This is the result. Let's have another example. Example number 5. Integrate. You are asked to integrate this. You are asked integration of sine of ax plus b into cos of ax plus b. Integrate. Okay, so you have to write integration of sine of ax plus b into cos of ax plus b dx. Okay, now see here, derivative of sine is cos here only. Okay, inside we have the same function, so put either of one, you have to put ax, sine ax plus b is equal to 2, you have to put. Differentiate with respect to x, so derivative of sine is cos ax plus b. Remember, further it is a composite function, sine ಒಳಗಡೆ ಏನಿದೆ ax plus b ಇದೆ, ಇದರ ಡೆರಿವೇಟಿವ್ ನು ಬರಿಬೇಕಾಗುತ್ತೆ. So further derivative of ax is a equals to dt by dx. Remember, okay, this is very important. how a has come. A is derivative of ax plus b. B derivative is 0. Now you transfer dx this side. It is dt by a this side. ಯಾಕೆ ಅಂತಂದ್ರೆ ನಮಗೆ ಇದು ಬೇಕು. We want the value of this. Okay. So call it as 1. So 1 becomes I is equal to integration of sine, you are replaced as t, and the second term you got dt by a. Look at this. This is your t, what? And this is your dt by a. So remember that. So integration of t is t square by 2 and this 1 by a constant as it is plus c. It's 1 by 2a and what is t? You have taken it as sine, so it is sine square ax plus b. Okay, because t is sine of ax plus b and its square is sine square ax plus b. So this is your I. Okay. Let us have an next example. Sixth one. Integrate square root of ax plus b. Okay. So let I equal to integration of square root of ax plus b into dx. So I can write it in the form of ax plus b power half. Okay. So now if I put derivative of ax plus b is, it is a only. So it can be made by multiplying dividing by a. So that is another option. Otherwise put this. Put ax plus b is equals to t differentiate with respect to x. So you will get a is equal to derivative of ax is a, derivative of b is 0, you will get dt by dx, and from this you transfer this dx this side. I want the value of dx equal to dt by a. Okay, so you got the value of dx as dt by a. So this is your 1. Okay, so 1 becomes I equals to integration of what we had, ax plus b power half means t power half, dx means dt by a. Okay, look at this, we have dx and dx is dt by a. Now you need to integrate 1 by a constant outside, better you write t power half dt for understanding. Okay, it's a 1 by a. Integration of t power n is t power n plus 1 by n plus 1. So you can write t power half plus 1 by half plus 1 plus constant c, so which is equals to 1 by a t power 3 by 2 by 3 by 2 plus c. I can write it as a 2 up by 3a. T means your ax plus b power 3 by 2 plus c. This is your required integral. Okay. So again, one thing to be noted, as I mentioned earlier also, integration of f of x power n into f dash is always f of x power n plus 1 by n plus 1. Okay, so let's have another example. Integrate, this is example number 7. So in this exercise almost there are 39 questions, and let's see how much I could able to finish in this session. Integrate x root x plus 2 with respect to x. Okay. So let I is equal to integration of x into root of x plus 2 dx. Now make substitution here. Put x plus 2 is equal to t, and from this you will get x is equals to t minus 2. Okay, differentiate this with respect to x. So what you'll get, this side it is 1 derivative of t with respect to x is dt by dx, and derivative of 2 is 0. So this gives you dx is equals to dt. Bring this dx this side. Okay, so what I becomes, look here, x means t minus 2, and inside the root we have x plus 2. X plus 2 means t. Dx is dt. Okay, dx is dt. Now see here, this can be integrated very easily. T into root t minus 2 into root t dt. Multiply this t into root t. So t into root t can be written as t power 1 plus 1 by 2. One can directly write t root t is t power 3 by 2. Okay. Okay, in the power of n convert and then integrate. Integration of t power 3 by 2 will get minus 2 into t power half. Okay, 1 plus 1 by 2 is 2 into 1, 2, 2 plus 1, 3 by 2. Okay, now you can apply the integral formula, that is x power n, that is t power 3 by 2 plus 1 by 3 by 2 plus 1 minus 2 into t power 1 by 2 plus 1 by 1 by 2 plus 1 plus constant c. So this gives you t power 5 by 2 by 5 by 2 minus 2 into t power 3 by 2 by 3 by 2 plus c. So you may write 2 by 5, t power, t is taken as, you have taken t as x plus 2. So x plus 2 power 5 by 2 minus 2 into 2, 4, it becomes 4 by 3. T means x plus 2 power 3 by 2 plus c. Okay, because t is what? Your t is x plus 2. Let's have another example. So I want to finish 10 examples of this exercise. So example number 8, let us call I is equal to integral of x into root of 1 plus 2 x square dx. Okay, you are asked to integrate this. Okay, now look here, derivative of x square is 2x, so we want x into dx, so that is here. So derivative of x square, you will get term with x. So put directly. So its derivative can be made within the integral. So put 1 plus 2x square equal to t. Differentiate with respect to x. 0 plus derivative of this. Derivative of x square is 2x. So 2 into 2x equals to dt by dx. And from this, x into dx equals to dt by 2. Why x dx means, look at this. We have here, this can be written in this form. Better you write down there. Okay. So x dx I have written. So therefore, your I becomes integration of this 1 plus 2x means t. So it is root t and x dx is dt by 2. Okay. So it is 1 by 2 integration of root t means t power half. This by 2 taken outside. 1 by 2 integration of t power half is t power half plus 1 by half plus 1 plus c, which is equals to 1 by 2 into t power 3 by 2 by 3 by 2 plus c. So these two cuts, 1 by 3, t means your t is 1 plus 2 x square to the power 3 by 2 plus c. This is your final result. Okay. So let's have another example. This is question number 9. I is equal to 4x plus 2 into integration of x square plus x plus 1 dx. So make one some arrangement here. If I take 2 common from this, what you will get? 2x plus 1 root of x square plus x plus 1 dx. Now clearly look at this. What is the derivative of this? Derivative of x square is 2x and derivative of x is 1. So clearly its derivative is here. So I can write it as 2 into root of x square plus x plus 1 into 2x plus 1 dx. Okay, so its derivative is here. Substitute. So put x square plus x plus 1 is equal to t. Its differentiation is 2x plus 1 is equal to dt by dx. Differentiating with respect to x. So 2x plus 1 into dx is equals to dt. So this is your I call it as 1. Okay. So what 1 becomes? Therefore 1 becomes I equals to 2 as it is, integration this root t and this is your dt. 2x plus 1 into dx is dt, and integrate it. Integration of root t. Root t means t power half. It is half plus 1 by half plus 1 plus c, or one can write directly it is t root t or t power 3 by 2. Okay, so this is 4 by 3. Your t is x square plus x plus 1 to the power 3 by 2 plus c. Okay, I hope you understand. Last one of the session. 10th one. Let us I is equals to, you are given this to integrate. You are asked to integrate 1 by x minus root x. Okay. So I can take, actually x means what? X means it is root x into root x. Note down this. Root x into root x is x. So there are two root x's multiplied. So I can take one root x, or better write in this fashion. This x can be written as root x into root x. So I will take one root x outside and you left with root x minus 1 into dx. Okay. Now if you substitute this, put root x, minus 1 equals to t. So its differentiation will be, if you differentiate with respect to x, derivative of root x is 1 by 2 root x equal to dt by dx. So we have 1 by root x here. So I keep it as 1 by root x, this dx up and to this side. So what I becomes then? Okay, 1 by root x dx is 2 dt. So I can write it as I is equals to, it is 1 by t into 2 dt. How? See here, you may write it as, to understand better, I can write like this, root x minus 1 into 1 by root x dx. So this is your dt and this is 1 by t. Okay, 2 dt. So it is integration of 2 as it is, integration of 1 by t dt. Okay, so this is 2 log t. So 2 log of what is t? You have taken it as x square plus x plus, sorry, it is not that, t is your root x minus 1. Okay, so these are the 10 examples of exercise 7.2. More 29 examples are there, so I require another 2 sessions for completing 7.2. So keep watching and keep studying.